Chapter 9, Number 31. An air-track cart with mass m1 equals 0.32 kilograms and initial speed of v0 equals 0.85 meters per second collides with and sticks to a second cart that is at rest initially. If the mass of the second cart is m2 equals 0.44 kilograms, how much kinetic energy is lost as a result of the collision? And clearly what we want to do here is find the final speed vf, so that we can use k equals a half mvf for both cases. So we're going to look at this and say the collision and the sticking is assumed to be internal, or as Velcro or something like that, and therefore the momentum is conserved. So thus P initial equals P final. And P initial is just going to be m1 v0. And P final is going to be, well, they stuck together, so it's m1 plus m2 times their final velocity. So we can solve this over and say, well, then the final velocity of the combined mass is something like m1 v0 over the sum of the masses. Now we want to talk about kinetic energies. The initial kinetic energy is 1/2 m1 v0 squared. And the final kinetic energy is 1/2 m1 plus m2 times the final velocity squared. But we can actually more or less simplify that. We can say, well, this is 1/2 m1 plus m2, and then over here, using this result, we end up with m1 over m1 plus m2 times v0 squared. And so we have a half, and we still have the m1 plus m2, and here we get m1 squared over m1 plus m2 squared, v0 squared. And you might wonder why we would do that. It seems a little maddening, but we can see a couple things. We can see, first of all, that one of these powers cancel. And then I'm going to play a little bit of a math game, and I'm going to say, well, I can pull out as an m1 v0 squared, and we're left with an m1 over an m1 plus m2. And I do that because this is just k0. So we have something like that. So we can say that here we have 1/2 times the 0.32 kilograms times the 0.85 meters per second quantity squared, which is 0.1156 joules. And then down for kf, we would have that 0.1156 joules times the ratio 30.32 kilograms over 0.32 kilograms plus 0.44 kilograms, which is 0.0487 joules. So finally, delta K, which of course is just Kf minus K initial, turns out to be 0.04867 joules minus 0.1156 joules, which is minus 0.06693 joules, which really, because we have at best 2 sig figs, is really something like 0.067 joules. So that's the change in kinetic energy. There's sort of this linguistic glitch always about when they say how much energy is lost. We would probably say that what's lost, what we lose, is 0.067 joules. In other words, the word lose takes care of the minus sign. I try and avoid phrasing like that because the English is a little weird. Also, you would have been perfectly fine of just finding VF straight up first and then just plugging in for K0 and KF. You didn't have to go through this this algebraic rigmarole. It's just sort of interesting to say the fractional change is sort of always the same, which is kind of neat.